similarities between an isosceles and an equilateral triangle? Tell me anything you know, or know that
About
they're
the
same or
differences
different.
between them.
Same, different, one or the other. I'll take anything to start out.
Okay. Both of them have all acute angles. The isosceles only has two equal sides. The
Okay,
equilateral
so you gotta
has three.
actually gotta pause there. An isosceles can have an obtuse angle. Not the way this one is drawn, but let's say it looks like this. This would be an obtuse angle potentially.
That's true.
The,
All
the,
right.
the, the base angles are never obtuse. That's true. But you gotta be careful. Like geometry's that like, it's so super particular. One word makes all the difference. Yeah. Um, I'm looking just to be more specific. We're either talking about sides or angles in terms of like what's the same and what's different. We'll kind of narrow your focus there a little bit.
Okay. Um,
So how many sides are congruent in an isosceles triangle?
no, two,
Two. How about an equilateral triangle?
three, or wait,
And
two, right?
I'm sorry, isosceles is two, equilateral is three.
Uh,
How about angles now?
and isosceles. I mean,
Yes.
I guess it'll have two equal angles.
Right. So sometimes students say same sides, same angles. They're referring to the base angles though. And what about an equilateral triangle?
All equal sides.
Angles now.
Oh,
You said sides. What do you know about all the angles in equilateral triangle?
they're gonna be equal.
Yes. And we can actually be more specific since all the angles add up to 180 degrees. Each angle is 60 degrees for sure, without exception. Is that okay?
Hmm.
All right. Do you have something down in your notes from this? Because we're going to use this in the next couple of problems that we're going to work on.
Um, I don't like have this in particular, like in my notes.
Okay.
Um,
Do you have down something about the base angles and isosceles triangles being congruent? Sides are congruent. Equilateral triangles, all angles, all sides are congruent.
oh yeah, I have scaling if and only if it has equal sides, and then isosceles, same thing. Collateral, I have obtuse, right, acute, and equal angular.
Okay, so you're doing a bit more than just isosceles and equilateral, sounds like. Is that
Hmm.
fair to say?
Yeah.
Okay. All right, so I'm going to put up something else here. And one of these will be true. Every isosceles triangle is equilateral, or every equilateral did you see this in class?
Um,
Sorry, I'm trying to just make it larger here. Which is true? Is every isosceles triangle equilateral, or is every equilateral triangle isosceles?
The second, every equilateral triangle is isosceles.
Yes. It's kind of very similar to the like, is every square a rectangle or is
Hmm.
every rectangle a square?
Yeah.
Good, good. Okay. We will address some of the other stuff, but with you, I know that one of the things we're trying to emphasize is some algebra skills. So I want to look at some problems here with you. Um, so we're going to first focus on angles. Okay. First talk about angles. And first thing I've got you have you do is tell me whether this is an isosceles or an equilateral triangle.
Isosceles
Why? Why is it isosceles?
because it has two equal sides.
Right. Which means that the base angles are congruent. The base angles are not the ones at the bottom. Like if this were inverted, they could be at the top. They're across from the congruent sides. And that meaning the base would be at the top now. Is that clear? Like, did you cover that in class?
I think so.
So what would this angle on the left be in terms of is it 40 or is it X?
I'm sorry.
This angle down here, is it 40 or
Oh,
is it X?
it'd be X,
It'd be X. And what do you know about the sum of the interior angle measure in a triangle? What do all the angles in a triangle add up to?
180.
All right, so you could write an equation here, X plus 40 equals 180. Will you solve for X, please?
70.
Yes, good. All right, let's try another one here. All right, I'd like you to solve for X, please.
That would be 72.
Okay, how did you come up with that?
54 plus 54, and then 180 minus 108.
Okay, very good. Right. So these are kind of the warm-up ones. Then they get more difficult from here. So I mean not like extremely difficult, but um, let's try one more of these. All right, could you find the measure of angle A, please?
88.
Okay. How did you come up with that?
46 plus 46, and then 180 minus 92.
All right. So the next ones will be more difficult. I should probably put that up first. All right. So here's the triangle. Okay, and there's no angle measures this time. This first problem is just expressions. What is the expression for angle S? Is it 2x plus 2 or 3x plus 1?
2x plus 2.
And what do we know about the sum of the interior angles in a triangle?
They'll equal 180.
Yeah, so could you add these three together? This is where you'll probably need that scratch paper. So what you don't do is you don't set the angles equal to each other because then you'll just get nothing. So you have to do the sum here. So could you solve this equation for x first, please?
Oh, X. Oh, sure. I'm actually not quite sure how to solve this.
Okay,
I'm
so
realizing,
let's add the like terms. So 2x plus 2x plus 3x, what does that add up to? How many x's?
uh, 2x plus 2x plus 3x,
Yes. Yes.
7x,
And then you have plus 2 plus 2 plus 1.
5.
Do you feel like you can solve this now?
I'll try.
So you undo, just keep in mind, you undo addition and subtraction before multiplication and division. So you look at the side with the variable, you're going to undo addition and subtraction before multiplication and division.
Okay.
Give that a try, please.
So now I just have like 7x equals 180, and then
No,
if,
you're subtracting 5 from both sides, so it should be 175.
oh,
That's
oh,
what I mean by
oops.
you undo addition subtraction first. So how do you undo this 7 in front of the x? What's the math operation between them?
Division.
Yeah, it's multiplying, so you undo with division. What does x become?
Oh,
You're welcome to use a calculator. If you need one, I'll put one in the chat here. You know, this isn't meant to be,
1T5.
yeah, this isn't meant to be like most challenging thing in the world. But I get it. Like if you're just not in the math mode, you know, or you don't use quarters, like we used to have to roll up quarters all the time, and you started learning how many were in each of these. Okay, now that's kind of part one. Let's say I wanted the measure of angle S. Like that was really the question. What would we do with that 25?
Um, multiply by 2.
So your expression for S is 2x plus 2. So you're going to take that 25 and put it back in. The 2 times 25 plus 2. What does that become?
P2.
Say that again. 52? Yeah.
Mm-hmm.
And let's say I wanted the measure of angle R. What would you do to find the measure of angle R?
That would be 76.
Yes. And what would the measure of angle T be without calculating it based on the fact that it's an isosceles triangle?
52.
52. Now, do those three add up to 180?
52 was 52 plus 76.
Yeah.
Yeah.
Yes, they do. Good. Okay, take a deep breath. The next one is similar. Uh, I think it's good to write out the other angle, meaning like what is M, angle M here? Is it 4y minus 15 or is it 7y?
4y minus 15.
Yes, and we know that the three angles add up to 180. So you've got 4y minus 15 plus 4y minus 15 plus 7y equals 180. Will you solve that for y for us, please?
Mm. All right. Oh wait, hold on. So y equals 10.
Okay. So I want you to
um,
put that back in and find the measure of angle N, the measure of angle O, and the measure of angle N. Fourth, please.
Okay. M equals 25. O equals 25. Then N equals 130.
Oh, I'm sorry. You did the gave me in a different order. Um, so okay. if your answer is correct, uh, then it would be 70, 25, and 25. I heard some different numbers. We're just putting that back into these right here. Now, do these add up to 180?
No.
So there's a mistake or problem over here with our variable.
Ah,
Okay, and that's that. The reason I let you continue through this because I wanted you to see that. Like, if you got this on a test and you're like, okay, there's my answer. Like, it's reasonableness. Is this correct? It's like when you put the toothpick in the, you're baking something to see if it's done. Like, well, I think it's done. Well, you check. So these are not right, obviously. So we're gonna reset here. Um, 4y plus 4y plus 7y is 15y. Minus 15 is minus 30. So you solve this by adding 30 to both sides. Remember, you undo subtraction with addition.
oh, I see what I
And
did.
there's your difference. So um, do this for me. If you need to, grab a calculator, but give me the better value for y. What is the better value of y?
Um, 14.
Yes, very good. So now I want you to put that back in to each of these. 7 times 14.
Okay, so I have n equals 98, o equals 41, m equals 41.
All right, that worked. Those add up. Okay, what do you think? Are these you kind of getting the hang of these?
I think so.
Yeah, you're doing really well here. I'd like you to do one more just because that last one didn't quite get all the way through. Like sometimes your answer makes sense. You get a number, you're like, all right, but that's why you carry it all the way through and see, okay, did I actually get, does it work? Okay. So is this missing angle here? Which one is it? Is it 4x plus 1 or is it 5x minus 4?
4x plus 1.
Yes. So just like before, we're going to add these together. All right, so will you try solving this for me, please?
Okay. All right. I so for D and E, I have
All right, just
57.
yeah, just give me the value of x first, and then we'll get to that.
Oh,
What did you?
14.
Oh, really? It's 14. Okay, you said measure of angle D. What? I
Oh,
interrupted you. I apologize. But what are the angle measures then? Did you put this back in? That's what I thought you were about to tell me.
oh, sorry. For the wait, now I'm confused. Um,
Why don't you just reset and tell me what you're going to say originally. I did interrupt you and I didn't mean to. Um
okay. Um, so for D and E, I have 57,
okay, agreed.
and for F, I have 66.
Okay. Do these add up to 180?
Yeah.
They do. Got to say it with more certainty. Yes, they do. All right, so we've been focusing a ton on angles. You agree with that?
Yeah.
And that's okay. I mean, that's normal. Especially on isosceles ones because they're kind of all related. The reason you don't see as many with equilateral is because they're all 60, so there's not a lot that you can do there. They tend to focus more on the sides with the equilateral triangle problems. These are just generalizations. And I'm focusing more on the algebra, because that was one of the things that mom had mentioned. Hey, let's work a little bit more on that. Um, get you stronger going forward. So here is An equilateral triangle. How do you know when you look at this that it is an equilateral triangle?
Because of the little curved things on the angles.
Yes, all the angles are congruent. Absolutely. All right, so now all the sides are congruent, which means that 3x minus 4 equals 5x minus 12. Now, as a reminder, when you solve equations with variables on both sides, you tend to move from the smaller to the larger. Do you remember us doing that before?
Yeah.
Okay. Will you attempt to solve this for us, please?
Mm. So I right now have 3x equals 5x minus 8, but I don't really know what to do from here because uh
Did you subtract the 3x from both sides? That's what I meant by moving from the smaller to the larger.
oh I did, I added 4 to both sides because I thought I was supposed to do.
It's the variable. You move the variable first.
Oh, like, okay.
So this is -4 equals 2x minus 12. We're going to solve a couple of more of these, but you move from the smaller to the larger. So the 3x is smaller than the 5x. That's why um, you moved it over. Now, what do you do to solve for x? Look at the side with the variable. You undo addition and subtraction before multiplication division. So you want to undo this minus 12 first.
So x equals 4.
You're going to add 12 to both sides. You get 2x equals 8, and then you're right, x equals 4. Good. All right, now I want you to put 4 back in each of those.
So df is 8 and ef is 8.
So both of them are 8, correct?
Yeah.
Okay, very good. All right. So let's look at another one here. it's kind of the same setup where you know that it's an equilateral triangle, plus I'm telling you, plus that's all we're working on. So you know that all the sides are congruent. All the sides are congruent. So same, all sides the same, uh, like that. The um, next thing is to set the two sides equal to each other. So 10x plus 3 equals 3x plus 24. This time you move from the smaller to the larger. You want to move the 3x to the 10x side.
Oh, x equals 3.
Now, could you put that back into the equation and give me the length of kj and kl, please?
So k kj would be 33 and kl would be 33.
Are you surprised that they're the same?
No.
Good. What is the perimeter of this triangle?
Let's see, that would be 99.
99. Good. Okay, fantastic. All right. Doing great. Um, let's see what else I can find here that might be worth doing. Um, all right, let me quickly look up some more problems here. All right, let me have you try this one on your own. Start to finish here. Just solve for x and then find the length of AB at the end. So first get the value of x, then figure out AB.
X equals 5.
Okay. So to find AB, you can use either of these, but you might put 5 back into both just to make sure that you get the same answer.
Okay. So for the A one, that would be 21.
Okay.
And then for the B one, that would be 21 too.
Okay. So what is A to B?
21.
Very good. All right. Let's see what else what else could be there. So like I said, it's either angles or sides that you're typically looking at. Here's a problem that is maybe deceptive because you're not sure what to do here. It's a triangle. They're telling you these two angles are 60. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean for this third angle over here? 60 degrees. What does that mean What's the angle measure of this third one if these two are 60?
60.
It's also 60, yeah. Okay. So what kind of triangle is this?
An equilateral.
Which means that all the sides are equal. So you could write like 2y plus 6 equals 5x minus 3. Why is this bad? Why do you think this is bad?
Um,
The issue here is you have two variables and one equation. You can't solve for either of them. But what you can do is you can use this 4. You can set 2y plus 6 equal to 4 and 5x minus 3 equal to 4. So I'd like you to solve each of these for the indicated variable, please. And you do get fractions, and that's okay.
and I'm just solving for y and x.
Yes, yes. Two separate equations, though.
Okay. Okay, so I have y equals -1 and x equals 5/7.
Other way around, 7 over 5.
Oh,
Maybe you wrote the right thing but said the wrong thing. I'm not sure. But you're always dividing by the number in front of x.
right.
All right, we are going to stop there for today.